Okay, we're solving linear systems by graph, or simultaneous equations by graphing. The first thing you want to do is draw a reasonably precise graph where you can plot the points reasonably exact. If you use a grid paper, even better, because the solution will be via graph. And then we're going to use algebraic ways to confirm it. So we're going to go through 3 steps. But before I go through the 3 steps, here are the 2 equations that we're going to graph and find a solution to. The first one up the top is 2x plus y equals 5. And the second line, linear equation, is 5x minus 3y equals 7. We're going to draw these guys up here on the graph. We're going to see if we have a solution, which means we have an intersection point. So that's step number 1. Draw the graphs. Step number 2, find that intersection point and read off those coordinates. Take that ordered pair and substitute step number 3 back into here to confirm that left-hand side equals right-hand side, which means if that happens, it means our graph is precise and accurate. So let's go through step number 1 and sketch these graphs. So in order for us to sketch them, let's mark out each of these linear equations. The top one, let's call it equation 1, and the bottom one, let's call it equation 2. Now let's graph the top one. So I'm going to draw a plot. I'm going to plot it with x and y. So for the top one, we got x and we got y. Let's just put 3 points, 1, 2, and 3. You could put 0, 1, 2, 3, but 3 points will do. And the next thing I want to do is write this in such a way that y is the subject, so we can find the y points, 3 points, so we can plot them on the graph. So let's make y the subject on the top one. So we're going to have y equals. Now take that 2x on this side of the equals. The 2x will become negative, so it'll be negative 2x. And we have a plus 5 already on the right-hand side, plus 5. So there's our new equation there. Y equals negative 2x plus 5. All we did, it's the same as number 1, but we made y the subject. So that's still our equation 1. Let's substitute x equals 1, x equals 2, and x equals 3 in here and see what we get for the y values. And then we're going to plot it right there so we can sketch that line. So let's go with x equals 1. Let's substitute x equals 1 in here. So if we put x equals 1, it's going to be negative 2 times 1, which is negative 2, plus 5. Negative 2 plus 5 is going to be a positive 3. So we're going to get 3 here. So let me just mark in the 3. Now let's go to the next point. X equals 2. Let's substitute x equals 2 right here. Replace the x with a 2. Negative 2 times positive 2 is negative 4. Plus 5, that's going to give us a value of negative 4 plus 5, that's a positive 1. Okay, let's go for the next point. X equals 3. Let's put x equals 3 into the equation. There. Negative 2 times positive 3, that's going to be negative 6. Negative 6 plus 5. Negative 6 plus 5, that's going to give us negative 1. Okay, we have 3 points that we can plot on the graph. For the top one, number 1. So let's go ahead and plot them. 1, 3. Let's mark out 1, 3. 1, 3, right there. So let's mark that out. 1, 3 is right there. Then we have 2, 1. Let's find 2, 1. 2, 1 would be right there. Okay, we have 1, 3. Oh. 1, 3, sorry, I marked it wrong. That's 1, 3. 1, 3, up there, that's better. X first, Y second. 1, 3, good. 2, 1, good. Next point is 3, negative 1. 3 on the X, negative 1, which means would be down here. There's negative 1 there. Okay, 3, negative 1. Let's mark that up there. 3, negative 1. Looks like we've got sort of a straight line happening there, reasonably accurate. Okay, so let me just mark it out. So that's going to look kind of like this. All right. There we go. And that's the equation number 1, which is 2x plus y equals 5. So I'm going to write it down over here. 2x plus y equals 5. So that's 2x plus y equals 5. There's our line right there. Okay, so we got the first equation all drawn up. Let's go for the second equation. 5x minus 3y equals 7. I want to make y the subject here. So let me just create some space here. Okay, put a little mark there. All right, let's make y the subject. I'm going to take the 3y and bring it over to that side. So on this side, we're going to have 3y. And I'm going to take the 5x onto this side, so it's going to equal minus 5x. So we just swapped them. So 3y went on this side. There it is. And 5x on the other side, minus 5x. Actually, no. 3y equals 5x. 3y is equals 5x. Okay, 3y equals 5x. Bring the 7 over here, so it's going to be minus 7. Okay, let's simplify this even further. Let's divide throughout by 3. So that means we've got y equals 5 on 3x minus 7 on 3. All right, let's draw an x and y so we can plot this. So we've got an x, we have a y. Let's do the same as before. 1, 2, 3. 1, 2, 3. Okay, this is equation number 2. Let's start substituting our x values. 1, 2, 3. Put it into there, see what y values we actually get. So let's start substituting. So y equals 5 on 3 times x. Now what's x here? X equals 1. So let's see, 1 times 5 on 3 will give us, let's see, that's going to give us 5 on 3. When x equals 1, 5 on 3, minus 7 on 3. 5 minus 7, that's minus 2/3. Minus 2/3. So 1 will be minus 2/3. So let's put it in there. Minus 2/3. Okay, let's put 2 in there. Let's substitute 2. 2. All right, for 2, x equals 2, let's put it into there. So that means our y equals 5 on 3 times 2. 5 on 3 times 2 over 1 minus 7 on 3. So that equals 10 on 3 minus 7 on 3, which equals 10 minus 7, 3 on 3, which equals 1. So we got a big 1 right over here, 2, 1. Okay, that's our second point. Let me just create some more space. Let's go for the third point, x equals 3. Let's substitute x equals 3 on that. So that's going to give us y is equal to 5 on 3 times 3 minus 7 on 3. Okay, 3 5s are 15. 15 on 3 minus 7 on 3, which equals 15 minus 7, that's 8 on 3, which equals 2. Divide the bottom to the top. 2 3s are 6 and 2/3. 2 and 2/3. 2 and 2/3. 2 and 2/3. All right, let's plot these guys up on the number plan. Let me just rub this out first. You could pick another 3 points if you wanted to. Would have been easy to put 0 in there, but that's good enough. Okay, let's draw the second graph. All right, 1 negative 2/3. 1 negative 2/3, that's going to give us a point 1. X equals 1, negative 2/3. 1 negative 2/3 will be about there. It's not even negative 1, it's 1 negative 2/3. About there. Okay, that's our point. Next point is 2, 1. So let's find 2, 1. 2, 1, it's the same point right there. It's the same point. Same point exactly. Then we have 3, 2 and 2/3. 3, 2 and 2/3. So that's going to be 3, 2 and 2/3. That's going to be up to about there. So it's about 2/3, roughly about there. So we have a line going through these points along here. So let me just put in a line. Okay, that's reasonably close. There we have it. There's our second line. So let me just mark out what that one's called. So this line is 5x minus 3y equals 7. Okay, 5x minus 3y equals 7. There's our line right there. Now that we've graphed it, that was step number 1. Let's go to step number 2, which is to read any intersection point so we can find the solution. So if I was to read this, I can see that point is common. We have 2, 1. So 2, 1 is the point we have here. So let me just mark that out. The ordinate is x equals 2, y equals 1. So there's our intersection point. We have solved it graphically. Now to confirm that our graphs are precise and accurate, we're going to take the points x equals 2 and y equals 1 and substitute back into either one of these two equations. You can do it in both if you want. I'm just going to do them in one of them. I'm going to substitute in the top one. I'm going to put the x and y in there. So let's go ahead and try this out. Let's see if we're pretty accurate. So we've got 2 times x, and our x is 2. So it's 2 times 2 plus y. What's our y? Plus y is 1. Should equal 5. So let's work it out. 2 2s are 4. 4 plus 1 equals 5. Yes, it does. 5 equals 5. So that works. So that point works. You know what? Actually, I'm going to substitute in the second one too to double confirm. That's going to give us even more accuracy. So let me just do that too. So let me just rub that out. So that point is validated. Let's try it again with the second one. Let's substitute 2, 1. So it's 5 times 2, x equals 2, minus 3 times y equals 1, and that should equal 7. 2 5s are 10, minus 3 should equal 7. 10 minus 3 is 7 equals 7. So yes, that is correct. So our ordered pair, the coordinates for solving this graphically, as we read it off here, is x equals 2 and y equals 1.